In this lesson, we're looking at area. So we think about area is the amount of shape that is inside of a 2D object. And when we measure it, it's measured in our square units. So if it's centimetres squared, metres squared, whatever it might be. So we've got this flow chart, which we drew similar for our unit conversions. But the only difference here is that when we multiply by 1,000 to turn kilometres to metres squared, we have to make sure it's 1,000 squared. So we actually end up multiplying by 1,000,000. So just be mindful that you have those squareds on there when you do those conversions. And then our division's the same. We divide by whatever that unit was. So millimetres to centimetres was 10. So millimetres squared to centimetres squared is dividing by 10 squared. Then got this extra conversion here. So going from hectares to metres squared. So there's 10,000 metres squared in a hectare. So we've got that there as well. So if we look at the example, we've got 12 metres squared to centimetres squared. So if we look metres squared to centimetres squared, so 12 metres squared, and I'm converting it to centimetres, so I have to times by 100 squared. So it means I'm multiplying it by 10,000. So then I'm going to go 120,000 centimetres squared. This one here, I'm going 546 metres squared, and I'm converting it to hectares. So from metres squared to hectares, I divide by 10,000. So that is going to look at if I draw my little curves where necessary. This is where my decimal point is after the 6, and I need to divide it and move that decimal place 4 places. So 1, 2, 3, 4. So 0.0546 HA for hectares. And the last one, I'm going kilometres squared to hectares. So I don't have a conversion for that. So in order to do this, I need to convert my kilometres squared into metres squared. So I'm going 1.2 kilometres squared, and to turn it into metres squared, I'm multiplying by 1,000 squared. So multiplying it by 1,000,000. So that means I'm moving my decimal point 1 and then 5 more. So I'm going to have 5 zeros. So I end up with 1, 2, 1, 2, 3, 4, 5. So we get 1,200,000 metres squared. And then from my metres squared, I need to convert it into hectares. So I'm dividing that by 10,000. So moving my decimal point back in 4 places. So 1, 2, 3, 4. So I end up with 120 hectares. So sometimes we can be asked to do more than one conversion, and we just need to make sure we go step by step. What we're going to do in the table below is just fill in the shapes, the formula, and an example. So the formula for the area of a square is S squared. So S is for side. And our example, we think if we've got a square depicted with each of those, and we say one side is 7 centimetres, our area is side squared, so 7 squared, which becomes 49 centimetres squared. And we always put the units on the end here. For a rectangle, we have A equals BH. This means that B is the base and H is the perpendicular height. So if we think about the shape for our rectangle, these sides are the same and these are the same. This is 5 centimetres and this is 3. Our area is BH. So our base is 5, our height is 3, giving us 15 centimetres squared. Now with all of these questions, you need to have 3 lines of working out. The first line is your formula, the second line is the substitution, and the last line is your answer. Now we have a triangle. Triangle can be 1/2 BH, or you could have BH all over 2. It doesn't matter the way you write it. B is the base, H is the height, same as above. So if we have a triangle, I'm going to draw an obtuse angle triangle so we can see where we get some of these measurements from. So our height here is going to be 4 centimetres and the base is 3 centimetres, and that's sort of a little right angle there. So area is half BH, so a half times the base times the height. Base times height gives us 12, and half of that then is 6 centimetres squared. A parallelogram is simply a rectangle pushed on its side, so it has the same formula. Area is base times height. So if we think a slanted rectangle, okay, and we've got a perpendicular height, we always need that perpendicular height. That's 6 centimetres and the base is 10 centimetres. Our area is base times height, which is 10 times 6, giving us 60 centimetres squared. Now, trapezium is a little bit trickier. I think this one is on your formula sheet, but you need to know what it is. And I think it's written a little bit differently on the formula sheet. But a half A plus B H. I think in the formula sheet it might be H over 2A plus B. Okay, so just know that there's two different ways that could be written. H is again our perpendicular height, and A and B are the parallel sides. So if we draw our trapezium, it could be drawn like this. So if that's 7 metres, that's 5 metres, and that's 10 metres. Or it could be drawn like this, okay? Same thing, that's 5 metres, 7 metres, 10 metres. So you could see a trapezium in either format there. If we use our formula, so a half, there's really a multiplication sign there, remember that between the brackets. A and B are the two parallel sides, so if we think parallel is shown with our little arrows, so 7 plus 10, and multiplied by the height. And if we work that all out, we end up at 42.5 metres squared. So a little bit trickier, that one. Then we go to our rhombus and our kite. So the area for this is a half xy. Now x and y are the diagonals. So a rhombus is either a square pushed on its side or what we know a kite to look like that. So if we think our two diagonals are these two across here, so if we say that is 8 metres and our longer one is 10 metres, area is a half xy, so a half times 8 times 10, it doesn't matter the order, which gives us 40 metres squared. 2 to go, we have a circle. So area equals pi r squared. We know that r is our radius. And pi is obviously 3.14, but we need to use that button on our calculator. So if we have our circle, we have our radius, okay, from the centre. So pi r squared, pi times 20 squared. And we put that into our calculator and we end up with either 400 pi. Now this is what we call our exact value. If a question asks an exact value, that's how you leave it. Otherwise, you can round it to the specified number of decimal places. And that is to 1 dp. Then you've got the area of a sector. So we still use the area of a circle, but we also need to know that we need to find the size of the angle. So if we think theta, so our Greek symbol for angle, over 360 because there's 360 degrees in a circle, and then we multiply it by the area of a circle. So we know that r is our radius and theta is the size of the angle. So if we go to draw our sector of a circle or our piece of a pie, the radius will be the same, and then our angle will be given to us as well. So we have area equals theta over 360 times pi r squared. So our angle is 45 over 360 times pi times 5 squared. And if we put that in, we end up with 9.8 centimetres squared to 1 decimal place. So please make sure with every question like this, we have 3 lines of working. The first is your formula, second is your substitution, and the last line is your answer with those units squared.